Okay, now we're going to move into 6.2, which is all about rational exponents. So I want to remind you that you do know what this word means. Rational implies a fraction. So we're going to be seeing fractional exponents here. And we're also going to be tying them back to our radical notation. Okay, so our first form of rational exponents that they typically present themselves with is this idea of a, so we have a base, 1 over, and then n, so where n is also another number besides 1. So I'm just going to come over here and make that note that n cannot be 1, because if n is 1, then that's not very helpful for us in terms of talking about a rational exponent, because that would make that 1 over 1. So if we see a rational exponent of the form 1 over a number, so remember a is filled in with a number, and then we're talking about, well, most of the time, but if we're talking about an algebraic expression, then a can definitely be in that base position. So a to 1 over a number, we can translate that into our radical notation as the nth root of a. So if you notice, the denominator there of that power is the index on the radical. And then because this is an equivalency statement, so we said a to the 1 over n powered means the nth root of a, we can actually read that in reverse. We can actually read that as the nth root of a also means for us, or is equivalent in value to a to the 1 over n power. So when I say that word means, I'm talking about an equals, so we're equating value there. All right, so let's see our first example. So we're going to be rewriting without rational exponents, and we're going to simplify if possible. So here's our first example, 27 to the 1/3 power. Okay, so we definitely see a rational exponent. We have a fractional exponent. So the first thing that we're going to do is to rewrite that without the rational exponents, which means that we're going to need to use its radical notation form. So the denominator is the index of the radical, and then the base of that exponential expression is going to be the radicand. So our denominator goes to the index, and the base goes to the radicand. Now the cube root of 27, we've already seen that that does simplify, so we would actually respond as our final answer of 3, because the cube root of 27 will simplify for us. Okay, so let's look at a second one, and we're going to be using an algebraic expression here. All right, so I've got, let me go ahead and move over so we can have a little bit more room. A, B, C, right? So the product of A, B, C to the 1/5 power. I want to rewrite that without rational exponents and then simplify if possible. So again, without the rational exponent means that we want to be using its radical notation equivalent. So again, that denominator becomes our index on a radical, and the base, so this time the base has been set off for us with parentheses, so we need to make sure that full base is expressed underneath our radical symbol in our radicand position. So that's going to be really important. The full base is your radicand. Now I can't simplify that any further, so we're just going to leave it as is, and that would be my final answer there. So come back to the second installment of this video to see how we can rewrite using rational exponents.